Okay, let's do it. 4.3, proportions and percentages. So, just continuing our discussion of everyday math that you'll use, just in your life in general, like percentages. Before we really get into the examples that I've listed in the notes, I want to talk about how to just review how to convert between fractions, decimals, and percents, and back and forth and all that. So, fractions to. So if you already know how to do this stuff, you can skip ahead a little bit. Okay, fraction to decimal. Fraction to decimal, like something like 3/8. How do you get that as a decimal? You do long division. Okay, long division. Numerator divided by denominator. Okay, you say how many times can 8 go into 3? That's 0. Okay, then you start the decimal part and you stick a 0 back there behind the 3. Now you just treat it like 30. How many times does 8 go into 30? 3 times. Start proceeding by long division as normal. Then stack another 0 behind the dividend here and then drop it. And then how many times does 8 go into 60? 7 times. Okay. Subtract, stack another 0, drop it right there. How many times does 8 go into 40? And you just keep going, keep stacking zeros until you reach that point where you have a 0 remainder. You could have a situation where you start to notice a repetition, but in this case, it just stopped at 0. So that's it. It's 3/8 is 0.375. If you don't feel like doing all this, just plug it into a calculator. 3 divided by 8. Calculator is going to tell you what it is. Cool. How do you go from decimal now to percent? So to go from a decimal to a percent, all you do is you move the decimal point 2 places to the right. So this number would turn from 0.375 to 37.5 with the percent symbol at the back. Okay, so how do you go from fraction to percent? Well, you go from fraction to decimal and then to percent. And what's the way to say this little rule in the calculator of scooting the decimal point to the right by 2? You're multiplying by 100, right? So if I wanted to take 3/8 to get it to a percent, this is the way to do it on paper, right? Here and then here to here. But really, with a calculator, the way you would do it is in the calculator, you do 3 divided by 8 and then times 100. 3 divided by 8 is going to give you the 0.375. Times 100 is going to effectively scoot that decimal point out right twice for you, and that's going to give you, and then you've got to stick the percent sign on the back. So that's going to give you 37.5, and then you put the percent sign on the back. Or some people like to stick the percent sign there, so they're multiplying by 100%. That's legitimate too. And to go from percent to decimal, you just divide by 100. You'll have to do that a lot in the problems we're going to be looking at because especially in, I believe it's section 4.4. Yeah, section 4.4, we're going to be using percentages a lot. In fact, that's the title of section 4.4, using percentages. So you got to know how to convert a percentage to a decimal, because anytime you do math with a percentage, you need it written as a decimal number first. And remember, to write a percent as a decimal, you just divide by 100. So for instance, if I had something like 5.38%, that's the same as dividing by 100, 0.0538 as a decimal number. Cool. Okay, so that's that review out of the way. Maybe that review would have been a little bit more appropriate at the beginning of section 4.4, but because we'll be doing this more in section 4.4, but the percentages was in the title of this section, so I figured we'll get it out of the way there. Okay, so example 1 from the notes, and I'm just working straight through these examples, all the necessary techniques that you'll need for this section. For this whole chapter really can just be described with examples. Not a lot of abstract theory going on here. Okay, it says the following sample of adults between the ages of 25 and 34 reported whether they had a college degree or not. And then there's the table. So I'll go ahead and draw that table for convenience to have in front of me here. So we've got yes, no, total. So the people that said they have gone to college, and now keep in mind this is for this age group of 25 to 30. People that have a college degree is 373. People that don't is 629, and the total number of people that answered the survey is 1,002. And we're assuming they could only answer yes or no. There's no third category. So the sum of these is 1,002. So no funny business going on where you could answer like maybe or something like that. Question A says, what is the proportion of people who have a college degree? The proportion of people who have a college degree. Okay. So here, proportion just meaning some number out of a total. So the proportion of people who have a college degree would be that 373 out of 1,002. Based on this data, that's the proportion of people who have a college degree. So if we took this to be like some representative sample of the entire U.S., we could scale it up so that the bottom would be like 300 million, or however many people are in the U.S., and then see whatever we scaled the bottom up by, we could scale the top up by, and figure out how many people, according to this little sample of people, how many people in the U.S. have a college degree in this age range. Okay, so anyways, this is the answer for part A. It's a proportion of people who have a college degree. So the word proportion here not meaning exactly the same thing as it did in the last section where it was an equivalence of two ratios. What is the proportion of people who do not have a college degree? So similarly, this is going to be 629 over the total. So it's the words proportion here, they're very much related to what we were doing last time, but it just means some number out of a total in this case. Oh, and I should put my, well, no, I don't need units here because of the context of the problem. Okay, part C says to write both of these numbers as percentages. Write both of these numbers as percentages. Okay. Do you remember how to do it in the calculator? Remember, all you do is you perform the division, literally do 373 divided by 1,002 times 100%. That's going to be your answer. If you don't want, if you're crazy and you want to do it by hand, you would set up the long division like this. You would say, okay, 1,002 goes into this 0 times, so I'd start stacking my zeros here. That's going to go in 3 times. That's going to give me 3006, and that's going to give me, let's see, 2, 4, 2, and 7, and then I'll stack another 0. That's going to go in 7 times. That's going to be 7014. Why am I doing this? I have a calculator. 622, add another 0. You're already done with the problem. You're just as frustrated as me. Why am I? Well, I've started it. I've got to finish it now. Okay, that's going to be 256, right? And then, what decimal place do we want to go to? Tell you what, I'll get one more decimal point here. So I'll stack another 0. Oops, there we go. That'll go in twice again. Wait a second, I messed something up, didn't I? Oh yeah, that was supposed to be a 2. Okay, 2004. Okay, etc., etc. So now I have a decimal number, which you guys already have via the calculator, and if I want to convert it to a percent, I would just multiply it by 100, which that's easy to do without a calculator, just shifting that decimal point to the right by 2. So I'm getting 37.22%. There's an issue with this, though. If I wanted to round to the 100th place, like I've done here, I stopped at the 100th place, I need to go one digit further so I know whether this 2 should round up to a 3 or if it does indeed stay as a 2. If you've done this with a calculator, then you know that the next digit is in fact a, what is it? I'm just going to ask the calculator what it is. 373 divided by 1002. The next digit is a 5. So the next digit is a 5 means that I should round this up to a 3, but I didn't know that, right? So all I could do for sure is actually say that my answer would be 37.2%, because I know that this 2 is going to make this, that rounds down, so it's safe to say this. Now the problem didn't specify what we should round to here. On an exam or in the homework, it will always specify. Alright, now let's do part B, or finding this as a percent. Let's do it a little bit more sanely. I will do 629 divided by 1002 in the calculator. I'm getting, I'll write it down here, 629 over 1002 is 0.62774445, etc. And writing that as a percent, I will have 62 and let's say I round to the 10th place again, then it will be 62.7, but it'll round up to 62.8%. Okay. Again, it'll specify in the problem what decimal place you should round your percent to. Okay. Example 2. The proportion of people who are left-handed is approximately 1 out of 11. So 1 out of 11 people is left-handed. Or I should say are left-handed. Or is, are, whatever. 1 out of 11 people are left-handed. And then the question is to estimate how many people in the room are left-handed. So clearly that's a problem that's typically I would use in a real, or rather a in-person class. Our class has roughly 35 people, so let's just assume that. So if 1 out of 11 people are left-handed, and we have a total of 35 people in our class, then we can set up a proportion that says X number of people in the class are left-handed, some number of people out of our total, and then we can cross-multiply. You've probably already got a feeling of what this answer should be. So I'm going to have 11x is equal to 35. Okay, so that means x is going to be 35 over 11. And that is giving me 3.18 repeating. So as a pure number, it's 3.18 repeating. In the context of the problem, it's saying to estimate how many people in this class are left-handed. I would say the estimate is closer to 3 than it is to 4, so I would say 3 people. 3 people, roughly, should be left-handed in our class, if our class is a good representative sample of the people that are left-handed. It's not guaranteed, right? It's not guaranteed. Okay. Example 3. Says a university has a freshman class with a ratio of 2 to 3 men to women. Okay. Oops. Okay. If 53% of the university-wide population, including freshmen, sophomores, juniors, and seniors, are male, is the proportion of female students higher in the freshman class or in the university-wide population? Okay, so one assumption we're making here is that there are only two genders here, right? So this problem's not the most woke problem. It's an old problem. I apologize for not updating my notes, but since I've already written it down and it's already typed out, we'll just stick with it. So we're going to assume this is a university where there's only the men and women, and in the freshman class, so just the freshman class, the ratio is 2 to 3. Okay. And university-wide, so including all freshmen, sophomore, every student, 53% of the population is male, or are male. So let me get that down. And then 50. So we have a few conflicting things going on here, or things that are going to make this problem harder to solve. 53% of university-wide population. University. The first thing is that this is not a ratio of women to total or men to total. It's men to women. This proportion, this percentage, is actually some number out of a total, right? 53% from a total. So let's get our number 2 to 3 here as a some ratio from a total, and we want to look at female students in particular. So first of all, actually, maybe the easiest thing to say is 47% of university-wide population are women, right? Because if 53% are men, then the other, to make up the rest of the 100%, assuming there's only two genders, would be 47%. Okay, now, for this ratio 2 to 3, we want that as a percentage, but not necessarily just 2 to 3, right? We want it to be women to total, and that's going to be 3 to 5, right? Kind of like that vehicle problem that we did at the end of the last section, where you've got to build a new ratio to get that total, but to get the total, you just take the sum of these two. So that's women to total. And also remember that this can be written as a fraction, 3 to 5. And every fraction can be written as a percentage. And I'm going to skip the steps here and just say that's 60%. Okay. This means 60% of the freshman class are women, whereas 47% of the university-wide population are women. So the proportion of female students is higher in the freshman class than it is overall in the entire university, which answers the question they wanted there. Okay. Example 4. Let's see, before I move on, is there anything else I can say about this to clarify? The point is, we're starting with a ratio, which it can be written as a fraction and as a percentage from the beginning, but you don't want to write it as a percentage until that denominator is a total, right? So the point is, if you've got a ratio and you've got some kind of percentage problem going on, you want a percentage of the total. So if you've got a ratio that's written as, men to women or something like that, and you want to know the percentage of women, then you've got to get it to be women to total. And the way to do that is to take the number associated with women, which is, in this is of course 3, and then its denominator should be the sum of both of these. So that's where I got the 5 from. And then from there, just converting it to a fraction, then to a percent, and then just comparing the percents. Okay, example 4 says, suppose you have a 72% as your homework grade. Oh, good. Okay, so this is definitely applicable to your real life because you have homework grades as percentages. You have a 72% homework grade. Homework is worth 80 points. How many percentage points do you have? I mean, how many homework points do you have? Okay, so the homework is worth 80 points. How many points have you earned? Well, you've earned 72% of them. So how do you figure out how many points you have? Well, this is like, if you remember solving percent problems, you've got a percent, you've got a base, and we want the amount. In other words, we're going to take the product of these two. We want 72% of 80, and that means to take the product, to multiply them. If we want to multiply 72% times 80, so that's times 80, we've got to get this as a decimal. Just like I said earlier, anytime you're doing math with a percent, like actually multiplying it by stuff or dividing it, you need to convert it to a decimal first. There we go. That's what you want there. So pop that into the calculator, 72%, so 0.72 times 80. So that's going to be 57.6 points out of 80. If you wanted to confirm, you could take 57.6 and divide it by 80 again, and you should get your 72%. Or when you multiply it by 100, you would get your 72%. Cool. Number 5 is much more straightforward. Write 56, okay. I guess I was just throwing that in there as a review. Kind of already done this, but that's okay. Oh. Example 5, write 56% as a fraction. Oh, maybe I didn't do one of these yet. That's okay. Alright, 56% as a fraction. There's a few ways we could do this. First thing, we could write it as a decimal pretty easily. Is that helpful? Yes, it is, because this is read as 56 hundredths, right? This is 56 hundredths. That's how you read this number. You don't say 0.56. If you want to be really technically correct, it's 56 hundredths. How do you write 56 hundredths as a fraction? Well, doesn't that just mean 56 over 100? Right, 56 hundredths. That's what this is. So it's a matter of turning it to a decimal, reading it in its technical sense, right? Reading it with the appropriate place value, and then just writing it like that. Writing it appropriately as it sounds, 56 hundredths. I mean, that's what 56 over 100, that's exactly what this number is, 56 hundredths. And then from there, just simplify. So I could pull a 2 out of both of these, of course. They're both even. What's that going to be? 28, right? I can pull another 2 out. That's going to give me 14 over 25, and that is not reducible anymore, so that's my answer. Let's do a bonus one like this. Let's do 35.2%. Let's do another one. Okay, write it as a decimal, 0.352, but if I read that technically, it's, how do we read that? 352 thousandths. Okay, so that means I'm going to have 352 over 1,000. Okay, good. Now it's written as a fraction. Now I just have to reduce it. So that's going to be, I definitely can pull a 2 out. Can I pull a 4 out of both? I think so. Let's see. I can pull a 4 out of both. Pulling a 4 out of 352 would be 25, 75, and then 85, 88. Yep. Okay. Ooh, I can pull another 2 out because they're both even still. Okay. Can this be reduced anymore? Let's see. 44 has factors 4 and 11, so it's built from 2 times 2 times 11, 125 is just 5 times 5 times 5, so no common factors. So that's it. So remember, if you want to be absolutely sure that your numbers have no common factors here, you have to write them in prime power factorization. So 44 is equal to 2 times 11, and 125 is equal to 5 times 5 times 5. Clearly there are no common factors here. So it's done. And if you want to be sure this is right, you can always just do 44 divided by 125 in the calculator, and you'll get 0.352. Good. What are we on? Example 6. Scooting right through this. Example 6. Darren went shopping, good, and spent $17 on scarves. Okay. If he spent $46 total, what percentage of his money did he spend on scarves? Round to the nearest percent. So when they say round to the nearest percent, that means once you have your percent as an answer, you round to the nearest whole number. Okay. Let's write down these dollar amounts. We've got $17. So that's scarf money. Then we've got his total. We want to know the percentage he spent on scarves. That's just going to be scarves out of total. That's what a percentage is. It's some number out of a total. So, and in fact, I can drop the money symbols here. They're not relevant because in the end, I'm just going to have it as a percent. How do I get this crazy fraction as a percent? Just divide. I get some terrible decimal number. Multiply by 100%, and I'm getting 36.9565 right? So once I multiply by 100, it's now a percent, right? They want me to round to the nearest whole percent, so I would say this is clearly going to round to 37%. So he spent 37% of his money on scarves. Cool. That is it. All right.